Greetings and welcome again. Just a very short video as a follow-up to my previous video. I want to just go over that conclusion because I didn't spend enough time on it. Let me just do that quickly. So I showed you in Vectoria's theorem, which is really just my historic geometric theorem with vectors. Okay, so I showed you in the conclusion that this proves that you don't need limit theory or any other drivel that you learned from your mainstream professors. Okay, what happens if you decide that you're going to let this vector, okay, this vector here go to zero? So if this vector becomes a point, then you're saying that this vector here becomes that vector, but this vector here never becomes this vector. Okay, it's always a non-parallel line. Now let's look at it from another point of view. Let's move it there. Now if we do this, okay, the same thing happens. You don't have the non-parallel secant line anymore. So you can't do that. It has to be greater than just a point. Now here's the other damning proof. The damning proof is this. If you do this, you don't have a difference quotient. Do you understand that? This is geometry you're dealing with. Okay, you're not dealing with real analysis or set theory or topology, all non-mathematical garbage. You're dealing with geometry, okay? This is vector arithmetic, and I'm showing you that you can't have h being zero, because if you do, okay, so look here, let me explain to you. If you look at this diagram here, you take the magnitude of t minus h over the magnitude of t, right? Don't you do that? So what's going to happen if you do this? Look, what's going to happen if you do this? You don't have h anymore when you do that. Okay? You can't do it. In other words, it's geometrically impossible to do what your idiot math professors and teachers tell you. And of course, to verify further, this here is the area, which is equal to the integral. Okay? So this area here is equal to the integral. Look, let me show you. Now, what did I do with my pen? Oh, there it is. Okay, so this here is equal to the integral from x to x plus h of f prime of x, which is this dotted green line, okay, with respect to dx. So Vectoria's theorem just really shows you everything in one glance with vectors, okay? That's all I wanted to say. If you're not already a subscriber, please become one. Click like, follow me on academia.edu. Goodbye.